Thank you so much, Mrs. Zoom. It's wonderful to be recorded. Welcome to the first NFTeasy Guild. As it says on the introduction page in the build section of the kernel syllabus, this is not a guild intended to make you into a shadowy supercoder. What we're going to do is take a very close, careful, and considerate look at the tools that we actually need in order to develop smart contracts, full stop. The most prevalent cultural use case for that at the moment seems to be NFTs. So that's what we're going to look at. And the intention is to give you the background, foundation, and technical skills required to write smart contracts of your own in general. We're going to use the public repository that has been set up for this guild in order to, as I say, walk through a particular NFT example, which is based on a book that I wrote and on code that I happily pirated from my dear friend Holly Grimm, who is an incredible developer based in the US. She leads natives in tech there and has a wonderful organization called Dynamic Culture, for which she wrote a very particular kind of NFT contract using GAN networks or generative adversarial networks to produce something called neuropunks. So if you're feeling particularly neural and particularly punkish, please feel free to check that out. This is where the code comes from, and Holly is the best. She is one of the mentors in kernel who you will be introduced to soon. And honestly, there are very few people in the world who I adore and love more. So thank you, Holly, wherever you are. We really appreciate it. The way that these guilds are run is as an open conversation. So I strongly encourage you, and it will delight me if you interrupt me constantly. It's really no fun for me to hear my own voice. I listen to it all day, every day anyway, and despite the fact that there are numerous different kinds that echo through my mind, it's wonderful to hear others as well. So please, no matter what kind of question you have, the floor is open. There is nothing too stupid, too simple, too off topic. These guilds are really intended as a peer-to-peer exploration of the space. I'm not going to present like the way of writing NFT contracts or the answer for how to write the most secure and optimized solidity. It's not within my skill set. I am not the world's best developer. I know only enough to be dangerous, and I do genuinely mean that. So please feel free to stop me. Feel free to talk a little bit about your own work. I know that there are some people on this call who are much better developers than me. So if I go off track, please correct me. I promise you I will appreciate it. And if you have questions, please ask them, because it can only improve these sessions, which, as I say, are not, like you'll find many other tutorials online which will take you through how to write and deploy your own NFT contracts in an hour. That's not what we're going to do. We're maybe going to get to deploying in like 6 to 8 hours from now. But that's intentional because I think that it's worth sort of taking our time to explore the space together and think quite considerately and carefully about what we're actually doing and why. As you know, kernel is very much a space about intentional approach to the work that we do. When we're clear about why we're doing what we're doing, and understand our intention for pursuing any kind of action in the world, then the effects of really genuinely acting from the heart are difficult to predict and generally delightful. So that applies equally to the development work and the coding that we do, just as it does to the relationships that we form and the way that we approach conversation with other human beings. These guilds are intended as a technical expression of the same basic ideas that you will find in the learn track. So with all of that said, if there are any questions before we begin, I will be very happy to hear your beautiful voices. Thank you for the heart, Ben. I love you too. Oh, it's on recording as well. I keep that. I have to remind myself.
Andy, it's Ben here. Just a quick question.
please.
Yeah, just when I followed the another track where you were talking about outsourcing contracts, and you talked about MetaMask. So no need to answer now, but maybe over the next 8 hours when you're explaining, within MetaMask, when you generate additional accounts, are they all completely orthogonal from each other? In other words, you know, as long as you don't transfer from one to the other, are there any way to chain from one to the other? I don't think you covered it when you were talking about the private and public key. So it's just something, if when we come to that, if you could address that, I'd be really grateful.
Wonderful. Incredible question. It's not directly related to what we're going to cover today, because we won't be touching MetaMask, but I will answer it as best I can. And maybe Martin Etzra can also help me on this, because as far as I understand, and I'm not 100% clear on this, but MetaMask has implemented HD trees, which are these, it means that your private keys are created in a tree-like structure, which means that they are linked, but not in a way which somebody could predict or get access to unless, as you say, you transferred funds between them. So there is like a tree structure behind the way that your accounts are formed, but it would not be apparent to anybody other than yourself as the account holder. Martin, you know.
Yeah, so I'm not, Andy, I'm not sure if I'm the right one to answer it, but still, I believe you're right that there's no, to my understanding, there's no way that you can infer another address from one that you generated, because it's generated independently.
Perfect. Thank you very much. Yeah.
Yeah, it's more just from a kind of a, I guess, a crypto hygiene point of view, because, you know, I did generate some addresses off the main MetaMask address, and that, you know, if or when we do deploy some NFTs, I'll put them into one of those addresses, but then I don't want that to leak into other addresses. It's you know, there's no sinister reason. It's just a hygiene thing.
Yeah, so from a hygiene perspective, generate as many addresses as you want. Nobody would be able to link them unless, as you say, you transferred funds between them. That would probably be a giveaway. It's not a deterministic link. The reason why it's interesting to know that there are this HD tree structure behind the way that your accounts are generated is that if you, you know, like your laptop gets destroyed and you decided to burn it in a cathartic fire ritual, and forgive my sense of humor on that, then, you know, you can go and get a new laptop, install MetaMask again, and use your 12 secret words to reinstantiate your accounts, and you could then regenerate exactly the same accounts from that seed.
Yeah, I've actually done that, and that's what made me, that's what kind of alarmed me a little bit, you know.
Okay, yes, yeah, cool. So that's the root of the question.
Okay, thank you.
Yes, it's if you have the seed, you can get the whole tree, like in any forest. But without that seed, nobody from the outside could tell.
Okay.
And it's a wonderful thing, because we are going to be talking about these trees, TRIE structures today, because it's part of what I have planned for tools. You know, I sort of lured you all in here with this promise of an NFT contract that sits in the GitHub repo, but I'm actually going to spend the majority of the guild session talking about tools, because like that's kind of my thing. Surprise. So we're going to start. One of the requirements, or the things that I asked you to do in terms of preparation, was to download these 4 tools: Git, Node, Yarn, and Hardhat. Yarn is not specifically required. I just prefer it as a package manager, and that's what we're going to sort of begin with today, rather than like diving directly into the GitHub repo, which is linked here, that we are going to look at in a moment. So we're going to spend some time speaking about these tools. And I have a very specific reason for wanting to do this, which is that there is a great difference between the words simple and easy. Now, in software development, often we will speak about how open source tools and the environments within which we work makes things really easy, because guaranteed somebody has run into the same problem you have, or the same set of needs, and so there's a tool or there's a solution on Stack Overflow where you can go and copy and paste the code that you need in order to solve your problem. but we don't really think about what the implications are of these different tools that we use, because they're digital and abstract. So we're one step away from them. Whereas if you ask a builder, like what the most important part of their craft is, it's the tools. There's a lot of efforts, thought, and intention that goes into the kind of hammer that you buy and the set of screwdrivers that you buy. And people prefer this torque wrench to that one because it has specific properties that other torque wrenches don't. And these things are very apparent and obvious when you're working with physical material goods in the quote unquote real world, but they become somewhat veiled when we look at an open source software repository on GitHub or Bitbucket or whatever it is, and it says, quick setup, install git node yarn hardhat. Okay, now we can do the thing. As if like these things are merely sort of incidental, peripheral things, not deeply to be considered. What is it that you're actually installing when you install git or node or hardhat? What are these things? What do they do? Why do we need them? Why do we like them? Why do we choose git over any other kind of source code management tool? These are actually kind of deep questions, and they can be very revealing. In particular, Git, which is what I want to speak about for some time at first, because it's one of the coolest tools that there is out there. And understanding the history of it really helps us understand a lot about crypto and what we're going to be building. So I thought that, yeah, it would be a nice way to kind of get into the foundations of how we build smart contracts by speaking about these things. And the history of Git is really interesting to look into. It was started in 2005 by a man called Linus Torvalds, who famously heads up the Linux project, Linux being the open source OS or operating system, which runs the vast majority of the web. And so consumer devices are still largely split between Windows and Mac, but 95% of the machines that serve information on the web are run by some flavor of Linux. This is because it's open source. It's very easy to get the ISO, the disk image, and put it on your server, and off you go. It's also, I won't get into the OS wars, but in 2005, the source code management system, the SCM, that the Linux project was using was something called BitKeeper. And there was this huge dust-up because the maintainer of BitKeeper pulled the copyright license. He'd been allowing people to use it for free, and he claimed that somebody making something called Source Puller, I think, had violated copyright, and so he pulled the free license from the BitKeeper software, which resulted in all sorts of unhappiness in the open source community, and in particular Linus Torvalds and the Linux kernel team, who have this massively distributed network of contributors and a very complicated project with lots of different moving pieces, suddenly found themselves in deep need of a source code management system which would allow them to manage multiple contributors, to do so in a distributed way, and to protect against malicious or ignorant actors, to be robust in these kinds of distributed environments. And at the time, in 2005, nothing like that existed. So Linus wrote Git himself in the course of a few weeks in April 2005. And as I say, his three goals in doing this were pretty clear, right? He said, I'm going to look at everything that these things called CVSs do, which is concurrent version systems, and I'm going to do the opposite, right? I don't want concurrent versioning. I want to have this distributed system with multiple different collaborators collaborating in a non-linear way. So non-concurrent, distributed, and non-linear, and it has to be robust. It needs to safeguard against corruption, both malicious and sort of just as a result of ignorance or lack of attention, which is often the case. We commit code that doesn't fully work or works on our machine, but not others, because we don't follow test-driven development practices properly, because it's a pain in the ass. So many different reasons why developers are a bit sloppy from time to time. Anyway, the third of these things, this thing of being sort of strongly guarding against corruption, is what led Linus and the people who built Git to use cryptography, right? Every single Git commit that you see, if you go to our repo here, you can see always in GitHub repos, there is this commit trail. Every single Git commit that you'll see has some hash, right? It's cryptographically linked to the commit before it, right? And this is how we build the commit tree. And it uses, in this case, SHA-1, which is slightly different from the SHA-3 algorithm that we use in blockchain. But it's really, really interesting because what you actually have in a Git repository is an entire tree with different branches, right? You'll see that in our NFTeasy repository here, there are different branches for each of these different lessons, and these different branches host radically different code. And yet they're based on the same commit history. And they all kind of link together into one common trunk, which is really interesting, and keep a good track of how many commits ahead or behind they are of other branches. The reason that I go into this is because what's actually at work beneath this particular source code management tool is a Merkle tree, right? It is a Merkle tree with a little bit more data in the nodes and the leaves, for those that know what that is. But the same structure, the same data structure that we use to get all of the transactions in a block, in a blockchain, into one single hash, which is the Merkle tree, is the same thing that you're seeing in Git. And the reason that I tell you all of this is because not only are these kinds of data structures and the sort of cryptography used to link them deterministically to one another, it's very much the case that I can't go back in even my public Git history and change this commit from September 25th without changing the hash of all of the commits that depend on it, right? So like in some very naive and simplistic sense, Git repositories are like an early version of blockchain, built by Linus sort of 4 years before the appearance of the Bitcoin white paper. But it gets better than that, right? Because like not only do you have this cryptographically linked commit history in every open source repository that you're looking at, the primitives that go into building Git are not actually what you would ordinarily expect from like a source code management tool, because it was built by Linus, right? It was built by somebody who is deeply concerned with file systems, with the kernel. And so most of the primitives kind of have to do with that. And in particular, there are these two really interesting ones, right? Which is that everything in Git is content addressable, and it has some notion of versioning associated with it as a result of the way that the cryptography is used. And I want to focus just a little bit on that thing of it's content addressable. Isn't that fascinating? Because when IPFS launched, everybody's like, oh my God, IPFS, it's incredible. We finally have content addressable web content. And that's wonderful. It means, like instead of some URL, which is a universal resource location, it says, this is basically me going to my local DNS, my domain name server, and saying, I want to know where the github.com human readable name, what IP address it resolves to. And then it sends me to this location where the content is hosted. And IPFS came along, they were like, forget this location-based rubbish, let's have content addressable stuff, which means that the content of the file is what determines where it is. So when I have a file, I hash its content, that hash becomes, in the case of IPFS, it's like QM something, 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 something. You just need to put that hash in and you always get the same content guaranteed. But that's been happening in Git since 2005. Git has content addressable stuff in it because it has these two data structures that are working in tandem in any kind of repository that you see, right? The one is the sort of mutable cache, often called a stage or an index, right? And that's what's going on when you're working in your files. You'll see in a moment now demonstrates what the cache is and how it works. That's while you haven't committed your changes, you're sort of doing what you need to do as a developer. But the other is this immutable append-only database, an object database for the developers in the room. And there are 5 things that go into this append-only immutable object database, which is kind of what you're looking at here, right, is the result of this object database. I can't go back and change what is in that first commit. I can only append new information in new commits on top of it, all of which are cryptographically linked. This is why many software developers, for instance, will say that, like, oh my God, why don't lawyers use Git, to version different contracts? Why don't bankers and accountants use Git to version different account objects or various other aspects of their system? Like, this is clearly the best way to do things, and it kind of is. But to sort of talk about this append-only immutable object database, there are 5 things which go into it. The first is a blob, right? What we call a blob, which is a binary large object, but it's just all of your file data, right? Whatever's in your file that you're working on at the time. I'm writing an NFT contract, that's in the blob, right? And the blob is what is the internal name of any blob in Git, for those developers that are interested, is the hash of its contents. The blob is what is content addressable, which is really fascinating. And then you have a tree, which is the directory structure. So it's this stuff here, all of the files in your directory. And that's kind of Merkleized into one commit. So you can see that, like, my directory is defined by this commit, which begins 95109A7, but the whole commit is actually, the whole hash is that. This entire hash represents everything in the tree at that point. And then you have commit tags and pack files, but I'm not gonna sort of go too much into that because I feel like we've talked mostly enough about Git. But I just want to say 2 things about this and why I've gone into such painstaking detail about something which is so much a part of our daily lives as developers, and which seems kind of simple, but underneath has all of these ideas which are directly applicable to crypto and show that none of the technology on a blockchain is anything new. And that's because, as I said, there's a big difference between simple and easy. And, easy, the etymology of the word easy, it means something which is near, right? It means it's near to me. And all of this stuff in software development is always near. It's just Git install this, or if you're a Ruby developer, get a Ruby fetch this hairball, is what they're called. And it's very, very different from simple. The etymology of the word simple means one twist, one thread, right? Simple is opposed to complex, which means many twists or many threads. Very complex or complicated, right? A hairball literally is a wonderful word for it in the Ruby system, because, like, that's what you're actually getting when you get something that's really near to you, that's very easy to find and fetch. You get this complicated, twisted hairball, which can often be, if you want to build something really beautiful, elegant, and which you truly understand, later on down the line, these things which are easy end up really being very difficult to untangle. Whereas if you understand from first principles the nature of the tools that you're using, then things flow in a much more natural way. You're thinking much more naturally. As I was saying somewhere else in the kernel stack yesterday, you're thinking in the same way that rain falls, or that birds sing, or bees pollinate. This is the way that we want to think, is along the lines of nature. And in order to do that, you need to be aware of these particular aspects of the tools that we use. So that's Git, and hopefully I've been able to demonstrate why, like, a lot of people online will say that, like, Git is basically the first blockchain. There are important differences, don't get me wrong, but this notion of cryptographically linked commits, append-only immutable database, Merkle trees, and content addressable stuff in blobs, it was all there. It's not a new invention. The other tools that I got you to install were Node. So when the web was getting going, one of the major languages which we use online, and which we discussed a little bit in our other guild session going through the Ethernauts tutorials, is JavaScript. And JavaScript used to exist really only in the script tags in your page. I'm not sure if we're going to be able to see them here, but this is some JavaScript in a script tag on your browser. And that's on the kernel site. That's kind of where JavaScript used to live, in these little script tags in the head of your HTML document or in its footer. And that was all wonderful, and you could do some cool stuff with it. But eventually, also in the early 2000s, people were like, well, I really like JavaScript, and I've spent all of this time learning how to write it for doing stuff in the browser. I want to be able to do other stuff with it too, talk to my server, update my database, and do all of this stuff. How do I get my JavaScript to run in a process in my computer, not just in my browser? That's what Node does, right? Node is a JavaScript runtime environment, which just means that it is the program which allows you to run JavaScript as a separate process on your computer, not in the browser. And that allows you to talk to your servers, and talk to your database, and write really terrible code that people who write C in assembly are going to cringe at and tell you that you're wasting your time with these high-level languages. And, oh my God, the libraries. Anyway, this Node for you. Yes,
yeah,
somebody has a question.
Before we go to Node, can we pause for a bit? Because I just want to discuss a few points about Git. Like, it took me 4 years of computer science to appreciate a few ideas that you just shared. So if someone has not gone through that journey, understanding trees and then content addressability won't be as fascinating for them. So, like, firstly, just visualizing a tree in computer science can help someone a lot. So like, just imagine a tree in physical world and just invert it, like a tree in computer science looks inverted. Then the concept, I think Andy's showing a Merkle tree could really help. So just like Andy described, different branches. So you have the root, which starts at the top, and then it's an inverted tree down. So that was the first concept that Andy described. So next, I think we can discuss content addressability, which was another big concept introduced in Git and IPFS. So in very simple terms, content addressability means that your ideas represent you, like your address is represented by what your content is. So if I'm a file with just one sentence, like hello world, so even if 10 million files have hello world, it would be represented by the same address only once. So that was the big step up in terms of representing things on the Git system. Like hello world will be addressed only once with one specific address all over the blockchain in the Git chain of hashes. So that saves a lot of space, first of all, and it also represents that one copy of any unique idea will be represented only once. So as you can see here, L1, L2, L3, these are unique addresses corresponding to unique ideas in that particular file. So these two ideas really blew my mind when I first studied them. And all of them were introduced later in Bitcoin as their first implementation. And I'll just quote Linus Torvalds when he described Git. He was honestly very frustrated with the version control systems of the day. And there's an entire talk about why he hated SVN or other systems like Mercurial and other things during the day, because they did not have all these features, like basically content addressability, which was the big one. So yeah.
Thank you so much. Yeah, there's I know when I was putting this talk together, I was like, well, we're skipping over a lot of history, but I would be more than happy to discuss sort of asynchronously with images and text and these kinds of things, as well as links to the talks that Sid has mentioned. If you would like to understand more about the deeper aspects of, for instance, the Merkle tree that is on screen at the moment, or content addressability, I'm trying, unfortunately, I think that's, we might struggle with this. I was trying to find my ENS domain, but I have not yet, I have not logged. Aha. So here is a book that I wrote, which is stored permanently on IPFS. And I would be more than happy to talk a little bit about content addressability in another tutorial, another session, specifically kind of focused on that, because it is like the whole world in itself. The intention with just speaking over these things is to try and give you a lay of the land in terms of the tools that we are using and why they're cool, why we use Git as opposed to something like SVN or Mercurial or these other versioning systems which do exist and are used in some other very specific software development ecosystems. But the nature of Git, the content addressability, the fact that it's distributed and can support, and is in fact built to support large numbers of different contributors, all contributing at the same time, all working off their own branches, all having their own local copies of the software, where there are more merges happening than any code getting written. You know, all of these things were really critical for the Linux kernel project, and have then been adopted by the wider open source ecosystem because they match our own needs so well. And it's a wonderful example of the kind of collaboration, modularity, and the reason why, for instance, Linux machines run 95% of the web, or why we, you know, the world's open source software is hosted using this protocol. It happens to be hosted on a centralized website now owned by Microsoft. Oh my God. But the point is that Git as a protocol itself is really, you know, in many ways, the first truly decentralized, not the first, but a truly decentralized blockchain of sorts, just not for money, for code. And that gives you some of the history as to where blockchains also come from, right? There's that, like, it didn't just appear in a vacuum out of nowhere. There were all of these other projects tackling all sorts of other things. And as is usually the case in software development, we're all selfish and introspective. And so we build the tools that we need for ourselves first. But then once we have those, the first thing we go after is money, hence blockchains. And now, hopefully, if we listen to people like Vitalik and others, there are ways of using these tools to do things more interesting than just money. Now that we have that primitive sort of functioning to at least the first approximation. Yeah, so as I say, Node is a JavaScript runtime environment. It lets me run JavaScript on my computer as opposed to in the browser. For the developers in the audience, it's event-driven. It's a non-blocking I/O, non-blocking input-output model, which is really good for asynchronous code. JavaScript is asynchronous. You tell it, hey, I want to do something, and it's like, okay, I promise you I'm going to do that, just wait, and it goes and fetches the information and brings it back. Node allows it to do all of that. And the way that it is structured, it has these modules, basically. And each module is a file. It's some kind of JavaScript file, which we run with Node. And that's these modules is where we get the infamous NPM from. NPM is the Node package manager. So when I write a tool in JavaScript that does some particular thing, I can package it, all the modules which make up that tool together, and I can release it into the wider open source ecosystem. And then everybody can use it and depend on it and never pay me and bemoan the problems of motivation, intrinsic or extrinsic, in open source software, which is also something that we're going to look at when we get to the terminal. Finally, Yarn is just a better way of managing Node packages. Also, we'll talk a little bit about that, but we've spent 40 minutes talking about tools, so I'm going to just move along to Hard Hat. which is the last kind of tool that I want to talk about. It's also, again, in order to understand the tool, it's worth talking a little bit of history, not as much as we did for Git, which is that, you know, in the early days of Ethereum, there were really two frameworks for developers to use, three, I suppose, if you include Remix. So, you know, Ethereum kind of gets going. If anybody was around for Lethio or the Olympic testnet, then you'll really know what I'm talking about, how difficult, you know, it was to develop software for the Ethereum virtual machine. It was basically impossible. There were no tools, no way of really interacting with or talking to this machine, which only speaks hexadecimal data, which we looked at in previous guilds in Ethernauts. You know, it's very, very difficult to speak hexadecimal data. You have to write some higher level language and then compile it down. So the first thing that we had to do that was Remix, which is still maintained by the Ethereum Foundation, and there's a really wonderful tool which we'll be discussing later on this week in the Solidity Guild. But very quickly, sort of concomitant with the development of MetaMask, out of consensus, another tool called Truffle came about. Truffle has always sort of sold itself as this Swiss Army knife for Ethereum, and it's presented a framework in which you could write your smart contracts, compile them easily, write tests for them, and connect them easily to your front end code, right? Because that was like, there were so many things to think about in writing your smart contract. It wasn't just like, okay, I have to learn a new language like Solidity or Slither or Viper. Then I have to understand which compiler version to use and what the different problems are with these different early compiler versions. Then I have to understand how to write tests in Solidity, which is basically impossible in the beginning, right? Because like you can only test so much with your like traditional testing tools like Mocha or Chai, which we're going to look at in this guild. But some things have to be tested with other smart contracts, and they have to be tested in live environments. And how do you do that with a blockchain? Very, very difficult. And not only do you have this problem with all the testing and debugging your smart contracts, so if you figure out that there is a problem in the Solidity code that you've written, how do you actually debug it? Is another whole guild that we could look at. But then also you have to connect it. You have to connect these contracts that you've written and the ABIs that come out of compiling them, these application binary interfaces, which declare the functions that you can call in your smart contracts to whatever front-end code you write. And Truffle did a really great job of that at first, but it was very heavily biased towards particular kinds of JavaScript front ends. Generally, at the beginning, it was sort of vanilla JavaScript, and then there were a few other kind of Truffle packages that you could use. But you know, because there was so many different moving parts in those early days of these Ethereum projects, the two major frameworks that came out, which were Truffle and Embark, were fairly opinionated about how to connect your contracts to your front-end code and what kind of code you could write on the front end, which tended to be limited to very particular kinds of JavaScript, which was good enough for the first few applications. But then like better developers come along and we want to write TypeScript and we want to do Vue and Angular and React Native and all of these things. And they make different assumptions about how information is handled and how data is passed in your application. And if you have a highly opinionated framework which specifies how you have to sort of connect your contracts that live on Ethereum to the front-end code, which allows people to interact with them from your website, it becomes very difficult to do. So Embark, which I worked for some time, began moving away from sort of tightly coupling your front-end code to your contracts, but was then rolled up into what is now Status Desktop and a particular project going on there. And so Hardhat came about, built by Nomic Labs and funded by the foundation. And Hardhat is this really sort of framework agnostic tool for writing, testing, compiling, debugging, and otherwise working with your smart contracts that makes no assumptions about what kind of front-end code or what tools you're going to use to serve it. And that's incredibly useful because what then can happen is you, instead of sort of specifying and tightly coupling your front-end and smart contract codes, you can develop a community that builds plugins, which is what Hardhat has done. And if you're interested in that kind of thing, I mean, it's also just like quite a profound point for those who are asking in the kernel stack at the moment about like, hey, how do we build community for a DeFi project or this kind of stuff? Well, you know, like look at Hard Hat and other projects like it, because building community is not just this kind of like lovey-dovey, unquantifiable people stuff that is important, but it actually all depends on the engineering that lives underneath whatever your project is doing, right? So the kernel website, for instance, is very, very clear about how to fork it, how the engineering has gone into making sure that it's completely open source, how to do translations, how to write for it, how to create your own content, because like that is what actually enables people to create educational materials in a shareable way with others that can hopefully replicate some of the processes that we run. And we thought very clearly and deeply about why we were going to do things that way before we built any kind of in-person community. And Hard Hat plugins are the same kind of example of this, just at a deeper technical level, right? Like if you go and look at the plugins, there are so many of them. And it's this kind of open architecture where we provide the bare minimum services that you need to develop your stuff in a very good, clear, fast, efficient, non-buggy way, hopefully. I mean, it's not always true for Hard Hats, but then like we provide the open architecture on top of that that allows you to build any number of plugins for what you need. So you can see that the Optimism team has built some plugins for Layer 2. The Aragon team has built some plugins for voting and governance. The Open Zeppelin team has built some stuff for upgrading contracts, which is quite a difficult thing to do. There's someone who's written a React plugin, all of these kinds of things. This is really interesting to think about if you're thinking about building community, because it really, in my opinion, and it is just an opinion, but like it starts here, and then is only enhanced, but not created by sort of good interpersonal human resource management. So that is the tools. Those are the tools. If you click the begin button, you will be taken to the lesson 0 branch of our NFTeasy tutorial. And before we begin, are there any questions about the vast array of tooling considerations that we have just gone through?
I have a question on the name Hard Hat. Where does it come from? Does it have a specific meaning?
I think it comes from the Biddle meme, is probably it. You know, that's in the Bitcoin community. There is this HODL meme, right? And it's actually like a fascinating case study of how memetics can be used to enhance monetary theory. So much of Bitcoin's monetary theory depends on this hard cap limit, and it depends on people holding it as some kind of security or investments. And this gets memed into wider public consciousness by this thing HODL, you know, where we've got diamond hands, and that is really critical to Bitcoin's survival in some way. Anyway, so that was something that they were rather successful at propagating, and Ethereum's sort of mirror of that was Biddle, right? BUIDL. It's not just about some kind of really simplistic investment or monetary strategy, but because we have a general purpose blockchain, which is not a calculator but a smartphone, we can do stuff with it. So, you know, forget this HODL stuff. Let's build stuff with it. And you know, Hard Hat, if you look, I mean, I think it's pretty clear on the homepage the reference to this kind of stuff. If my internet doesn't, there we go, you know, is very much the sort of build theme in Ethereum. So I think it's just that. But again, you know, like a simple question that points at like very different ideological streams which run beneath fairly similar tools, or a tool that has grown out of Bitcoin. And you know, a simple thing like this speaks volumes about the kinds of characters, personalities, and ideology that you see in different communities.
Yeah, I think the meme is also on the hard hat, the yellow hat, which construction workers use for constructing or building anything safely. So hard hat provides you a safe and productive environment to build Ethereum apps. So it's like the yellow hat you wear to stay safe while you build something.
Because right,
One other,
please.
yeah, one other question from chat from Justin Obi was, is it safe to say that what NPM is to Node is what hard hat is to Ethereum?
You know, yes, but at a different scale. Right, there are millions and millions and millions of node packages, which is something that we're going to talk about in the next guild or at the end of this one. There are not millions of hard hat plugins, and hopefully it will not end up in a similar position where like you end up in a part of the problem with the node package management stuff is that because there are millions of packages and because there are no incentives to really maintain them, many of these things are not maintained. Many of them have security problems. It's a nightmare to try and npm install anything and not get a stream of warnings, audits, and various other problems and unmet peer dependencies and all this kind of stuff when you do npm install anything. And so you will see that this is a problem which I'll talk about probably in the next guild. What I will say at this particular point is that one day I will npm install and there will be no warning, and I will know that we have entered the promised land and all will be well, and Labradors will be gamboling through fields of daisies with rainbows in the background, and open source software will have reached its apogee. But that day is not today. So, hopefully Hard Hat is able to figure out some way of incentivizing the maintenance, upkeep, and safety of the plugin ecosystem that they're creating. But it's not an easy thing to do. And a lot of what we've been talking about public goods funding and this kind of stuff, you will see what it's really all about in this guild. Okay, so NFTeasy.
I'm sorry, one other question. Are you going to share also some insight on the second step?
So I felt a little bit shy about this because it was pointed out to me that it is a little bit disinclusionary, which is not how I intended. So I apologize unreservedly for it coming across in that particular way. Because in Slack, Daniel makes some good points that, like Linux is by no means perfect. It's a benevolent dictatorship with some really kind of heavy-handed behavior and other things which are not necessarily very good or to be emulated or praised. And Mac has any number of its own problems, whether it's the package manager that they use, Brew, or just the fact that they, shipped a machine learning algorithm, one of these kind of adversarial networks that can undo most of their encryption to people in China, or the way that they do obsolescence engineering, or I could go on forever about the problems with each one of these things. But what I will say on this is that the link is worth watching. It's a YouTube video called Revolution OS, and it speaks about why having an open source kernel, why having an open source operating system is so critical. Because much like, if you think about language itself, right? Like the language that we speak informs not just the way that we express ourselves and the kinds of thoughts that we have, but the kinds of thoughts which it is possible to think, full stop, right? So it's not just the case that I can be more passionate in Spanish or more romantic in French or angrier in Afrikaans. These things are true, and there is like a sort of linguistic range for expressing that, which is sort of similar to the fact that I can do certain things in JavaScript that I can do much better in C, or I can do things in Python that I can't do in JavaScript, or whatever it is. But it goes deeper than this to the OS, which is that like the way in which this entire ontology, right? The way in which knowledge and communication and interaction and perception is framed by my computer limits the ways in which it is possible to think and interact in the first place, right? And Windows made some very specific choices about how they present their interface, and more than that, at a protocol level, about what DOS is and how it operates, right? Very different to Bash and the, I mean, like DOS and Linux are two completely different things. The underlying architecture is radically different, and so the nature of the use that arises from these different operating systems is very, very different. And people will often, I mean, it's not exactly true, because there, as Daniel, again, like these things are much more complex than what I'm presenting at the moment, and there are wonderful kind of like graphic editing and other kind of higher level things that you can do in Windows that you can't do with the equivalent software in Linux. But like many people in the software development community will call Windows an OS with training wheels, right? It's like riding a tricycle. That's the equivalent sort of metaphor. Whereas like having something which is truly open source, which is maintained by a community of people that are constantly looking at the code, constantly attacking the code, being attacked, improving it, patching it, merging it, updating it, as opposed to a closed cathedral-like situation like Microsoft, where you have Microsoft in cahoots with the NSA, who keeps a blue sky vault of all of the 0 days that they have into the Microsoft system that occasionally leaks to the wider web, and then everybody is buggered. And like you don't have those kind of problems. You don't have those kind of issues in an open source community, because everything is open by default. And so the nature of the interaction, the nature of the kinds of thoughts that you can come up with, and the nature of the way in which you actually use the stuff is very different. So
yeah.
Can you run Linux? Can you run it simultaneously on your Windows machine, or do you have to do like a hard?
Yes. So this machine
OS
that I'm
level
running at the moment is an HP machine, which came pre-installed with Windows. You can sort of do a disk partition and a dual boot.
Amazing.
So
perfect. That's all I needed to know.
Yeah, Mark, it's Ben here. I'm doing exactly the same. You can actually, within PowerShell now, they've upgraded it, so it has all of the, the sudo, the npm, all that kind of good stuff within that now. So if you have any issues, just give me a bell.
Yeah.
Thanks, Ben.
Yeah, and thanks for mentioning that, Ben, because PowerShell is like, if you are on Windows and you use it because you need Office or because you need media editing software, these kinds of things, like don't. This is a joke, I mean, like PowerShell is a good alternative. They also have like Bash alternatives from Windows 10, and that means that it's like easier to use your terminal or your command prompts and follow the same instructions which are given in most Git repositories and stuff. So
it's getting less hideous all the time.
It is, yeah. And like Microsoft is recommitted to open source. It's not an entirely terrible thing that they bought GitHub and this kind of stuff. You can see that there is a strategic change in direction from their leadership, which has more to do with supporting open source software. They still have misaligned incentives and these kinds of things, which we can talk about endlessly, but like they are better than the early days.
The CTO gave a talk there about a year or so ago, and he said that 4 out of 5 of all instances on Microsoft's cloud now are Linux.
Yeah, irony upon irony, isn't it?
There you go. Yeah.
Okay.
Yeah,
so
I mean, I just have one comment to say on point number 2. Like, it's important to understand from the principles of Web3. Like, we talk about Web3 or crypto being free and open source, and that's Linux was the first such open source effort. So when you use Linux, you're using the collective consciousness of more than 30 million lines of code contributed by more than, let's say, 20,000 contributors over the last 25 years. So before blockchain, that was the first such collaborative project at that scale. So yeah, whenever you use that, the free and open source means freedom and not free as in free beer. You can have a paid and open source project as well. So the principles of free and open source are very much carried forward to Web3 and crypto. So that's why you see so much overlap.
Yeah, thank you, Sid. Yeah, the collective consciousness is a really wonderful way to speak about it, because that's what it is. And the other point that I'll say is that in speaking about Git, one of the things that I didn't touch on was the fact that it was one of the first projects was GNU GPL licensed, which is the GNU general purpose license, which was written by a man called Richard Stallman, who was the guy who started the Free Software Foundation, free as in speech, not as in beer. And Sid is right that it's not just the collective consciousness captured in those lines of code by 20,000 plus contributors. It's the collective consciousness in the licensing. It's the collective consciousness in the very nature of the tool, the intention for building it, right? That's why we focus so much on intention in kernel. It's not some airy fairy, hippie woohoo notion. You can see the effect that it has in the nature of the tools that you use and how open they are, how easy it is to change, alter, adapt, and use them. And it comes through in all of these incredibly subtle but really important ways, particularly for people whose craft is to do with computers, right? Again, I can understand if your craft is not directly related to computers, then it's perfectly acceptable to use other OSs. There's no problem. And there are good reasons why you would for various different contexts that are not possible to cover in the course of this call. But yeah, what Sid says about collective consciousness is very powerful. Okay, so we've been through what we're actually looking at here in this Git repository. And the next thing that we're going to want to do is actually get the code that's here so we can begin to play around and do what it is we intended first to do in this tutorial before I hijacked you and spoke about tools for an hour, which is clone it onto our machine, make a local copy, and begin to explore what's going on here. So you should see, if you click this code dropdown, the ability to either clone using HTTPS, which I recommend, unless you are a developer and you've set up your own SSH keys, which if you're a developer and you haven't, please do. So I use SSH, but HTTPS is more accessible and requires less setup. You can copy the URL. And if you open your terminal or your command prompt, make sure that you're in a directory that you want to be in. You can see that's really good. Make sure that you can zoom in a little bit for you. Yeah, that's not working. This tilde here means your home directory. So I'm wanting to work in, I have a directory called kernel. I want to work in there. And if you've copied the URL, you can write git clone and paste your URL here. I'm using the SSH one, but you should have https://github.com. If you're having problems pasting it, either just right click and paste, or it's Control-Shift-V in my terminal on Linux. Might be Command-Shift-V or just Command-V if you're on Mac. And you should see this incredibly simple and easy clone that happens quite fast. I'm on really slow African internet, so that should be done very quickly for you. You can see here are the objects that we spoke about in describing the 5 different kinds of things that actually make up our immutable append-only object database. And now that I have the repository, I can change directory into it. I can use the lookup source command to take a look, and it's just a little package.json file and a README. The README is what I can see here. So that's got all of the information about the tutorial. And if I want to look at in the package, the file, I can use the cat command And it's got some information about the name and the version, the description, and authors, keywords, license, which you can see I've licensed this not even under GPL, but the Creative Commons zeros. So anybody can share this in any way that they please. The GPL license, the MIT license, the AGPL licenses, they're generally more widely used because they are share alike licenses, which means that you can use and adapt the software however you like, but if you share it, then you have to share it in the same way that it's been shared with you. Whereas Creative Commons just means it's completely open. Most of my work is CC0. That's depends.
So I just did ls, and then I also did cat package.json, but none of those commands are recognizable on a Windows device.
Yes. So somebody's going to have to help me with Windows commands for lookup.
Yeah, I have everything installed, by the way.
Yeah,
So
it's because your ls and cat are bash, right? The language that I'm speaking in this terminal, this like cd cat ls, that's bash, and Windows does not use.
Okay.
It doesn't use that. So you'll need Nomad. It's dir. Yeah, dir will.
There we go. Yes, dir. Thank you.
Yeah, you'll just keep like whenever I say cats or these kinds of things, just look for the equivalents. Yeah, you should be able to find them, and I'm sure that people will be able to help you in the chat. Sid has probably got all of them waiting. The next thing that we're going to do before we can look at our Open Zeppelin library contract, which is the main point of the next hour, is we have to install the framework that we've discussed, Hardhat, into this particular repo. So you'll see that GitHub these days has this neat little copy thing. We're going to use our Node package manager to install Hardhat at a specific version, and we're going to save it into our developer dependencies, which is this field in the package.json. So if you paste that particular line, npm install -- save -dev Hardhat at this particular version 2.6.4, you'll see what is happening now is Node is going and fetching the modules associated with this package. In this case, it's Hardhat at a particular version. It's doing a whole bunch of stuff. It takes a little while on my machine because my internet speed in my terminal happens in kilobytes and not megabytes because I live in rural South Africa. But it's wonderful because it allows me the opportunity to speak a little bit about what is actually going on in our terminal here, which, if you've ever wondered why people complain about the lack of extrinsic motivation and the problems of funding with open source software development, all you ever need to do is watch an npm install. We're really lucky here because the two ones that we're going to be looking at today, because they're new packages that are really put together predominantly for smart contracts and stuff, they've been well audited and have no vulnerabilities either in Hardhat or in Paulo. I think that
if
maybe,
you don't mind muting.
Thank you so much. So there are no vulnerabilities in this, which we'll look at tomorrow, but please carry on. Yeah.
Is there a reason you're using npm here instead of yarn?
I should have used yarn, and I actually like we don't need yarn. This is a mistake of mine in the tutorial, which I'm just realizing now, which is wonderful because it proves that we're here to make mistakes together. Yes, you could use yarn to do the same thing. Yarn is a better way, in fact, in many regards than npm to manage your packages, and I just forgot to do that when I was putting these tutorials together. So you could write yarn install save dev. It's the same same thing for the purposes of this tutorial. I prefer Yarn because it has better management of your lock files. So like now that we've installed this, and I'll come back and talk a little bit about like our stack trace there, but you'll see not only do we have our package.json, but we have a package lock.json. And this package lock.json is much longer, and it specifies all of the dependencies that were also installed with this package hardhat, along with their cryptographic hash, right? So that particular release of, let's have a look here, the particular release of core.js pure at this particular version gets hashed, and it has a content addressable thing which is put into my package lock.json. I mean, it's probably going to be ugly to show you this, but this is what I'm talking about. You can prove that it is indeed the package that you're looking at because it has this integrity field, and you can check it with a SHA-512 hash, and off you go. And this is a mess when you do like projects in production. NPM does not manage it well. You often get into really nasty merge conflicts in your Git repository between different people's versions of package lock.json. Yarn does a much better management of this with the yarn.lock file, and that's why I prefer it. Other people have different reasons for preferring Yarn to NPM. They both are used to manage node packages. The difference is in how they lock the versions so that you can be sure you're always using the same software as your collaborators. So thanks, Billy. I'm an idiot, and I should be using Yarn, but forgive me for that. The other thing that I wanted to show you while I scroll through, you should get a sense of some of the problems that we're going to look at with node packages, just by seeing how long this lock file is. But what I really wanted to show you is also this. Although the two packages that we're going to be looking at today, hardhat and the OpenZeppelin library contracts, have no vulnerabilities, you can see that even here, we're beginning to get into some of the problems of open source funding for software, to the point where the maintainer of the core.js repo, which is used for polyfilling JavaScript, which is like an important process and is used like across the ecosystem by basically everyone. He's like, hey guys, I really need some help with funding, and like if you could just like follow these links and maybe send me some cash. Also, here's a Bitcoin address. Oh, and I'm looking for a job. So, help me out. And that has kind of made its way into the install message in these different packages. This is the beginning of the problems that we begin to see with funding for open source. That's the egregore, which is the word that you can ask Kevin Owocki about. But the awareness of this problem in the wider ecosystem outside of developers is really not big. And even within developers, nobody ever looks at the stack trace, but this guy who's really amazing at the work that he does, Zed Loyrock, he's kind of left with his only option is to like fill my terminal with a few more extra lines, begging me to go to like Patreon or PayPal or to send Bitcoin to his address. So there's the beginning of some kind of solution there, but perhaps the good people from Gitcoin will have some additional thoughts that we can look at next guild when we do some other NPM or Yarn installs, which are going to cause us many more problems and much gnashing of teeth. The other thing that I've asked you to install here is the OpenZeppelin contracts. So if you copy that line and install them, you'll see a similar message because it runs through the whole tree, and we can see that there are no vulnerabilities. And it just gets worse and worse, right? 61 packages are looking for funding. So NPM have themselves put a command in our terminal where we can run npm fund to take a look at these things. But this is kind of the current state of open source funding. Like it's just, it's not good. And many of these things you'll see are sort of Ethereum-based projects, but many of them are not. Many of them are sort of core JavaScript repositories. And we can do better. We can do better than this, which is something to note for the moment. When we install our TypeScript dependencies next week, we're going to have a whole different story to discuss. But that's where we'll kind of leave this for now. What I want to do, having installed just these two things, the framework, Hardhat, that we're going to be using to develop for the next 4 weeks, and the libraries on which we're going to be depending for safe and secure template smart contracts. I want to go and take a look at those. So I'm using VS Code, which has this bash shortcode of code. You might be using Atom or some other text editor. I can open this repository directly from my terminal just by doing that. If you're a developer, that's a nice little hack. But if you're not, and if you're using a different code editing piece of software like Atom or Notepad++ or whatever floats your boats, then just go into your file directory. I'm in my kernel directory, and here is NFTeasy, and I can open that with Visual Studio Code. Whatever way works for you, whether it's from the Finder on Mac or from your Start menu on Windows or your File Finder on Ubuntu, you should be able to open some kind of text editing environment. Hopefully something like Visual Studio Code, because it'll make it easier to follow along. But there are many great editors. I use Visual Studio Code because it has this really neat feature of an integrated terminal, but so does Atom, many others. It's a really nice little thing, and I like both the integrated terminal and the extensions that they have. So you can see that I've got a really nice extension for MDX, which is what the kernel site is written in. The Solidity extension is really the most important one. And there's one for GraphQL, which is also kind of nice. I enjoy those extensions. But again, similar things exist for other code editors. So there's no strong preference on my end. If you're in here, the other nice thing about Visual Studio Code, which I'm not sure how many other text editors have, is that it has this integration with Git. And so, I mentioned when I was speaking about Git that there are two different kind of data structures in it. There's the immutable append-only object database. There's also the mutable index or cache or staging. And this cache or staging thing is what is causing my package.json to show up in a different color and have an M next to it. It's saying it's been modified from the most recent commits in my Git history. And it has been modified. I can even see where it's been modified, right? It's the two dev dependency packages that I installed, which were Hardhat and OpenZeppelin contracts. It might confuse you that we installed Hardhat 2.6.4, and for some reason it's 2.6.5 there, but that's just the caret that says, when I say install Hardhat at 2.6.4 with the caret, it says 2.6.4 or above. That's what the caret means. So there's a more recent version of Hardhat, which is why we now have 2.6.5. So yeah, this M and different color, it's coming from Git, and it's because of that other data structure. What I want to look at for the next probably 40 minutes or so, depending, maybe less, is our node modules folder, which no one ever opens because we just npm install this and it's easy and it's very close to us and we fetch it, and then we never look at, oh my God, oh, holy moly. I mean, just wow. If you've ever heard somebody out of computer science or somebody who's an assembly code developer who's written C or C++ or one of these kinds of languages, if they come into sort of web developments or anything to do with JavaScript and Node, and then they look at their Node modules folder, they're just like, why? Why are there so many things in there? We only installed two packages, and yet look at our Node modules, it's just endless. And how the hell am I supposed to know what all of the software does? And I'm not going to, please don't freak out, I'm not going to walk you through all of this. We're just going to look at the OpenZeppelin stuff, but just be aware that this is what I mean when I say things that are easy, that are nearby, are often the decrease in cost to fetch them because they're close and easy to get is directly proportional to the increase in complexity and security challenges and just general code maintenance that you have to look at in your project, right? And this is particularly true of like Node modules. What's neat and what's important to understand is that like these are only develop dependencies, right? So they're only while I'm developing the project locally. Your package.json will often have two different fields, dependencies and dev dependencies. Dependencies are like built into the application that you're going to be using, and those you have to be careful about because like they can cause problems, and it's really a huge headache to manage your dependencies because you can see it's just endless even with two packages, right? The dev dependencies we don't have to be as concerned about, and it is really encouraging that there were no problems with the Hardhat and the OpenZeppelin packages when we installed them in our terminal, right? So that there were no vulnerabilities. But that's not true for the larger ecosystem because they don't care about vulnerabilities as much as people building on blockchains do for obvious reasons. Anyway, we're in our Node modules folder, and the thing that we're going to be looking at most closely today, because it's what we're going to be building on, if you have looked through the repo, you'll see that we've got the smart contracts that we want to put together. And it has these two import statements, both of which come from the OpenZeppelin libraries. And so before we write this contracts and import those things, let's actually just take a look at our OpenZeppelin contract libraries and see what we get. Because this is the bright side of open source software development, right? Is that like you will all be very aware that over the years that Ethereum has existed, there have been numerous different hacks, often for extremely large amounts of money. It's not just the DAO hack, but also the parity wallet hack and various different DeFi protocols and Nexus Mutual. It's just endless. And through all of those hacks, right, because this is an open source environment, we've learned a great deal about what it means to write secure smart contracts, what the best kinds of patterns are, what the common gotchas are, all of these kinds of things. And it's one thing to be able to write like security checklists and this kind of thing for the best way to write smart contracts, but we can go much further than that, right? We can build these libraries of audited, provably secure contracts. And that's what you get with one line, I mean, like in our terminal, this is what we did. We did npm install OpenZeppelin contracts. And with that single line, this entire directory is what we get, right? We have contracts for managing access. We have contracts for different, don't worry about that. We have contracts for different kinds of payments. We have governance contracts. We have all of the different interfaces. We have different meta transaction contracts, which Austin Griffith will know a lot about. We have different proxy contracts, which is why OpenZeppelin has written that plugin for Hardhat, the updater, because it's difficult to manage these kinds of patterns when you're updating your contracts. We have different security and re-entrancy guards and different utilities, right, for all sorts of different kinds of things that you might want to do in all of the different contracts that you write, which we are going to use in these tutorials. And finally, you've got the token libraries, which is what we're going to spend our time focusing on today, because we're wanting to build NFT stuff, right? So you have the ERC20, which is just normal fungible tokens, been around for the longest time, has its own set of issues, but is widely used and deeply loved. And then the 721 contracts, which is what we're going to be using today. And for the rest of this guild. There are also, like, we'll take a little look at the 1155 contracts, which is the multi-token standard. I'll discuss a little bit about that. But today is 721 time. And you can see that for free, we, instead of having to go and follow a tutorial and understand what are the best patterns and all of the gotchas with Solidity and understanding, oh my God, what kind of compiler version do I have to use? And all of these different things, we can just npm or yarn install Open Zeppelin contracts. And here we are with audited and secure base layer that we can build our own contracts on top of. And whatever contracts we write end up looking very, very simple, right? We inherit all of the stuff that we need from these proven contracts and write only the logic that we're interested in adding in our own application. So it's, yeah, I'm just enormously grateful, particularly to the people at Open Zeppelin for the work that they do and for the fact that it is open source, that it's this easy to go and make sure that the code that I'm using, building on top of, relying on is trustworthy. It's really an incredible feeling to begin a project with, you know, that this is where we start. It's amazing. And, you know, we speak a lot about gratitude and these kinds of things, but again, like, this is what it feels like and looks like at a technical level, that I can just, in one line of code in my terminal, fetch years and years and years of collective learning from some very, very difficult lessons that the wider Ethereum community has gone through. So what is going on in this contract? I'm not going to read it exactly like line for line, because that's what we're doing in the other Solidity guild, but I will go over some of the more important aspects of things. The first is that it really matters what compiler version you use, because that is what results in the hexadecimal data, which gets deployed onto the chain and which the EVM reads. And specifying your compiler version is what allows you to verify your contracts on services like Etherscan, but also just in general. You have a whole bunch of import statements, which, as you can see, are using all kinds of utilities about like context strings and ERC-165, which is a particular EIP for interfaces, which we will look at in a moment. And then before we get into the contracts, it gives you some information about where this particular standard comes from. So if we go and take a look at that, you will see that there is an entire website, eips.ethereum.org, dedicated to all of the EIPs that have occurred.
Esa llamada viene ya con
And the the fascinating thing about this, as I was sort of talking about in the other guilds, that if you look at a website like ETH Research, you know, like, you don't need many stronger arguments for why these kinds of communities are really interesting long term. You know, it's not about like the marketing or this kind of particularly other directed projective speech, right? Like, so much of the stuff that actually happens in Ethereum in particular, I am biased in this regard though, but also elsewhere, is like, it's this kind of work, right, which is not fancy or particularly engaging from like a visual or even you know, easily comprehensible standpoint, but it is significant of the depth of work and the degree of exploration and the amount of people that have been involved with this over the years. There are thousands, and there are thousands of EIPs, all of which adhere to these like fairly simple but really comprehensive structures. So if you go and read the EIP 721 thing, there's some really fascinating little pieces that you can look at, which is like, this is a standard for non-fungible tokens, also known as deeds. Isn't that fascinating? Think about that from like a gaming perspective. a deed as in an action that I can take in a game, some sort of performative speech act on chain, or as it was originally intended, which is loans, burdens, other responsibilities, property rights, these kinds of title deeds. This is where this standard originated from and what we were thinking about when it was written. You can see physical property, virtual collectibles, and negative value assets. So fascinating. We haven't really seen much of this yet. Loans, burdens, other responsibilities. There are a number of people working on fractionalized NFTs, NFT lending protocols, this kind of stuff. It's a little bit more challenging than this single line suggests, but I recommend just having a look at these kinds of things because they describe in very succinct, sparse, and technical language the scope of possibilities with these different standards, and understanding why they came about can often give you great insight into how you might use them in interesting, novel, and creative ways. So the motivation for this is it's a standard interface. It was inspired by ERC 20, but we want to go easy. I mean, we want to go further because we need this thing where each asset is distinct. And then you can see that there's a full specification, right? Like every event that the contract has to implement, every function that it has to implement with a full set of comments is all here. The one thing that I will say about these comments, and again, I'm not going to read the whole thing because I don't want to bore you to death in our first session, but this comment is written in a style which we call NatSpec, developed by the Aragon team, which allows you to bubble up information about the nature of transactions that people are entering into on the front end because it's a standard. So if you are writing your own contract, it's critical that you comment your code always. I mean, just in general, if you're writing code, comment it, tell people what it does, because otherwise it's very, very difficult for other people to understand, pick up, help you work. And again, community and collaboration comes about as a result of clarity at the technical level. If you have that, and if it's easy for people to understand why you've implemented something the way that you have and how to understand it and therefore contribute to it, it becomes much easier to build community at the social levels. NatSpec is another great example of that kind of thing at a technical level.
Yeah, I'll just mention a side note here. So firstly, looking at these EIPs really makes me wonder how early we are in the whole crypto space. Like people think this is the current version of NFTs and this is it. But every year or so, we come up with a new concept in Web3, and this is where it takes place. Like these EIPs are where it generally starts. So there are a lot of EIPs which haven't been implemented yet, and it's honestly opportunities waiting to be implemented. So yeah, just take a look at all the EIPs that are there, even in the multi-token standard. Like we haven't even explored many kinds of tokens yet. So yeah, anyone can start an EIP. Like the names you saw up there are all results of many discussions on GitHub. And you can start an EIP. You do not need to be a programmer or anything. You just need to propose an EIP, and then yeah, you can build on top of it. So one more point was that Open Zeppelin, you build on the shoulders of those giants, but you should go with an open mind. Like Open Zeppelin also has vulnerabilities, and they have an excellent program to incentivize people to disclose them and share the findings. That's what keeps it secure. The community is what keeps all these protocols secure. So I'll just share one of the findings of one of the members that we have. So he recently exposed one of the vulnerabilities in one of the Open Zeppelin contracts. And you can see the journey of how you go from an EIP to disclosing a vulnerability to getting it fixed for the entire Web3 space. So yeah, that was my rant.
Thank you so much, Sid. I honestly don't know what I would do without you. I really very deeply appreciate it.
Just one other piece of ancient history as well is a lot of these kind of practices came out of telecoms. So in the ancient times, even pre-digital, it was all run by the ITU, the International Telecommunications Union, and then both 3GPP that regulate all the mobile telephony standards and the internet community realized that the speed that they worked at was just completely unworkable. So the IETF came up with these what's called RFCs, requests for comments, and all of the protocols for UDP, for curl, for SMTP, for TDP, for all of those protocols that all of this relies on. They're all in there. They're in exactly the same format. And it was because everyone realized that things were changing so fast. Like back when I started, it was Waze and it was Minix and it was Tannenbaum and all those guys. But very quickly the RFC community realized that they could iterate at a really, really fast speed. And whatever it was that became of interest, more people flocked into. And I think that's where maybe some of this EIP type practice came from.
Directly, yes. You're right that the RFCs from the IETF were a huge influence. My favorite one is on screen at the moment. It's RFC 7282, written by Pete Resnick. An incredible one about the governance processes that the IETF used, especially early in the 90s. The other place where the name EIP actually comes from is the Python improvement proposals. Many of the original contributors to Ethereum, including Piper Merriam, who's running the current core developer onboarding program. They're bringing on more core developers, and Piper is running that. He was a big part of the Python community, and PIPs had come from RFCs, and EIPs came from PIPs, and it's all one thing. It's the nerds change every 30 years or so, but the culture, the outlook, and the intention is very similar. So yeah, thank you for that history, Ben. It's really fascinating. So you can see the full technical specification here. Each of the functions that this contract called the ERC must implement. There are different keywords for different levels of requirements, as well as the events that it must fire. The comments describe exactly what is expected behavior for each of these functions. The interface describes what kind of what kind of interface should be implemented so that other contracts interacting with your contract can know whether it is a 721 contract or a ERC20 contract or an 1155 contract or whatever it is. This we'll get to ERC 165 in a moment. And then there are all of these extensions which are optional for the ERC 721 standard, which we will also take a look at. One has to do with metadata. You can add a name, a symbol, and a URI, which is a universal resource indicator, often to something like IPFS or Arweave or some other permanent data store. SIA is another potential one there, the Skynet. It defines what a metadata schema should look like in JSON, which is something that we'll also kind of take a look at, because there are some other ideas based on what Sid was saying that we're so early, there are hundreds and hundreds and hundreds of different ways to do these kinds of things. And then something that we'll be looking at today is the enumeration extension as well, which you'll see that there is nothing in, if you actually read through the full spec yourself in your own time, you'll see that there's nothing in the spec that says that the tokens have to be organized, your ERC 721 tokens have to be organized in an index. So if you just implement 721, you can have a token with index 19. It doesn't imply that there's an 18 and a 20. So we'll sort of have an enumerable extension to make sure that we do actually have a sensible index, which is something else that we will look at today. It implements these 3 additional functions, and we'll see that in our Open Zeppelin library in a moment. There's some caveats based particularly on the compiler version for Solidity that was available at the time when this standard was written. Interesting history to read. And then some interesting rationale, CryptoPunks were big already back then. Decentraland and the notion of land was a big part of the push for the standard. They talk a little bit about identifiers to make sure that it's unique, the different kinds of transfer mechanisms. And this transfer mechanism is also something that we will come back to in a moment when we talk about safe transfers from, and the kinds of things that you can do with those. But there's, as I say, like all sorts of really interesting history about metadata choices, privacy, community consensus, backwards compatibility, test cases, implementation, on and on and on and on. And this is just for 721, right? We can look at 165 as well, because if we look at our ERC 721 contract, it's importing all of these different things, which something for context from our utilities, which you'll look at, and then this strange ERC 165. You know, we need to try and understand what this thing is, and it's standard interface detection. So this was just written by Nick Johnson, who is the author of ENS, Christian Reitzweiner, who's the author of the Solidity compiler and Solidity itself. Fabian Fogelsteller is the author of ERC 20 and a number of other very important standards. And Jordi is a wonderful developer from Spain, very involved in some of the Catalonian stuff. Worked with Aragon for a while, helped the Status team with their initial sale, has been involved in different privacy. He's a lovely man. Big fan of Jordi. If he ever watches this, Jordi, we love you. And Conrad and William, who are also big parts of the early kind of ecosystem. And they were very aware that we needed some way for contracts to know what other contracts did, right? Because these contracts are just, they're not smart contracts, they're dumb scripts that live on a shared network, and dumb scripts need some dumb way of figuring out what other dumb scripts do. And the way to do that is to implement these standard interfaces. So 165 is just a way of saying, hey, this is what I do to other contracts, right? The technical specifics of that are like a little bit more involved in terms of understanding, but as long as you understand like all that this 165 is about is explaining clearly in common language to other contracts on the network what I do. That's what we're using it for. And then the convention is that if there is an I before the name of a contract, it's just the interface, right? So here we're talking the interface for the ERC 721 and the interface for the ERC 721 metadata contract. So how that works if you're not a developer is like here you will see like some function, for instance, balance of, which in the contract itself is where we put the logic, right? There's a require checks that it's not like, we're not querying, for instance, the address of the balance of the 0 address. And if that passes, then we return the balances of the owner, whoever was passed in here. So we do some stuff, you know, in the functions in our actual contracts, but in our interface, all we do is specify what the function is, right? No logic interfaces, just declare to other contracts, hello, this is what I do. I'm a 721 contract, and I'm a 721 contract that implements these specific functions. So it's just a nice way of being neighborly on Ethereum, if you think of it in a different metaphor. So yeah, we have a bunch of different declarations to do with our name, the symbol. This, as you can see, Solidity is strongly typed, which we mentioned in the previous guilds, that you have to declare whether something's a string, whether something's an address. We also have Booleans, we have enums, we have mappings, we have bytes 32, and we have uints 8, 16, 32, and 256, I think. Uint is an unsigned integer, and in this case, it's an unsigned integer of 256 bits. Generally speaking, we use them when we don't know how big our contracts are going to be. In this case, you know, how many owners we're going to have, or how many tokens they're going to hold, or how many people they're going to approve to manage those tokens on their behalf. So it's cool. I'll use a 256 uint, 256-bit uint. But if we want to optimize our contracts make sure that we don't use as much storage, therefore we use less gas. Sometimes we use UN8s or 16s or 32s. The constructor is what gets called once when we deploy a contract. In this case, when we deploy our ERC 721 contract, all that we're setting into memory is the name and the symbol associated with this contract. You'll see that we'll use that in a little moment. This is just ERC 165 support. We're running out of time, so I don't want to discuss too much about exactly what's going on here. I will discuss it in the next guild, talk a little bit about like the super keyword and the notion of parent contracts and one step up the hierarchy, this kind of stuff, because it's fun to talk about hierarchies in Ethereum, decentralized environments. That's for another time. What I suppose I want to do in the last 15 minutes is you can read through the exact logic of these contracts, which is very, very simple for the most part, right? There's nothing very complicated going on in the ERC 721 standard. No complicated maths, no particularly complicated logic. If you have problems, I'm willing to answer them asynchronously via text in the Slack channel. The only thing that I will talk about a little bit is these two URIs, which is that like often what we will do in writing these NFT contracts is like we'll say our base URI is, for instance, gateway.ipfs.io/ipfs. And then our token URI will simply be the content addressable hash in IPFS. It is more optimal from a storage perspective, and it just helps understand like where things actually are. So like your base URI is like, okay, I'm using this service, IPFS or Rweave or whatever service to store my data permanently. And then the token URI is that specific piece of hashed content, which will allow me to find deterministically and forever the content that I'm uploading. We will talk about permanency probably in the third guild, because again, it's a whole rabbit hole that we can have a bunch of fun in and talk about the heat death of the universe, entropy, all sorts of fun things if you like. Or we can just stay with IPFS and Rweave. We'll see what happens. We'll see how sort of nihilistic or existential we're feeling that particular day. But that's one thing to note here, the base URI and the token URI. I wouldn't worry too much about many of the other things. What I really want you all to do, just so that we can sort of get to the end of this tutorial, is create a new folder called contracts. And in it, create a file called babel.sol. So .sol is the Solidity extension. Babel is going to be the name of our contracts, because I was feeling heretical when I put this tutorial together. And you can copy the codes that I've put here, and we'll talk through sort of what's going on based on our brief dive into the Open Zeppelin node modules and what they actually provide us. Again, you can see that
you just created this Babel.sol?
Yes, so if you need to create in your directory, right, which I can have access to immediately here in VS Code. Other text editors different. Create a new folder, which is this button here, and call it contracts. Name, yeah. And then if you create a new file in it called babel.sol.
Thank you.
And then you can copy this code in the NFTeasy repository and paste it. So you can see that because I'm using Holly Grimm's delightful code for these tutorials, she licensed it under MIT, which is also a share-alike license. So that's what we're identifying up here, that this code is licensed under a particular thing. And we're specifying a compiler version for Solidity of 0.8.0 or above, right? So this little caret means or above. It's not, excuse me, it's not good practice in production contracts to use the caret. It's much better to specify exactly what compiler version you're going to be using, because then again, you can be much more clear about what your dependencies are and what's possible security implications that compiler version may have. For development, it's just a little bit easier, and it's not going to break your hard hat environments or this kind of stuff if we use a caret. So that's why we do for now. But if we were going to deploy these into production on the mainnet, it would be worth taking the time to remove that caret and to be very clear about which compiler we're using, because it has an effect on the actual hexadecimal bytecode that is deployed onto the network. Then in this contract, we're importing two things. The first is the ERC 721 URI storage. So it's not the contract that we were just looking at in our known modules, but another one, which I will briefly go over. And we're going to be using a utility from the OpenZeppelin libraries called counters, which is going to help us make sure that we have a comprehensible and sane index of token IDs for our Babel NFTs. The counters contracts, while we're not going to have time to look at it, is just what allows us to make sure that we increment properly and safely each particular token ID, and that we have, as I say, like a comprehensible index. And you can kind of see here, right, that's because we're saying, okay, before I discuss exactly how this constructor works, the last thing that I wanted to look at is we looked at the 721 contracts, but what we're actually inheriting here is from the extensions folder, and it's the URI storage. So if we look at that, then we say, okay, so this is just inheriting from the ERC 721 contract that we've looked at, and it is enabling us to set a token URI, which combines the base URI and whatever the token URIs is, which is what's going to allow us to reference some permanent store for the data associated with our non-fungible token. It allows us to set that token URI. The set token URI and the burn are internal functions, which you can always tell, by the way. There's another convention in Solidity that if you have an underscore before your function, it's generally an internal function, which means that it can't be called by anyone other than other functions in this contract. Whereas, for instance, here, token URI is a public function, and it can be, meaning it can be called by anyone. And it's what allows us to add the URI storage to our 721 contract. So that's what we're using to make sure that our Babel contract is, it's possible to have a URI associated with any book that we mint as an NFT in our Babel library. You can see that our constructor, when we call this, because it's Babel is an ERC 721 URI storage contract. ERC 721 URI storage is ERC 721, and ERC 721 has this constructor which is expecting a name and a symbol. So we've kind of followed the trail through that, and that's why with our constructor we're calling our ERC 721, which it's finding through the URI storage contract, and it's passing Babel as the name and lib as the symbol.
Got it. This gets to one question that was in the chat from Oika. What is symbol used for in a 721 contract? You may have just covered it, but
it's not a lot is the answer, Rich. Not a lot. when we write these standards, the idea is to try and make them as general and open as possible. So it is conceivable that you might have some use for a symbol as opposed to just a name for your 721 contract. It's much more understandable in the ERC20 standard, right? So that you would have like a name, the status network token, but SNT, because like that's much more closely associated with like a ticker from currency trading. And so people use the symbol much more than they do the name. Whereas with 721s, because it's this like unique asset, they tend to use the name CryptoPunk as opposed to the symbol. But it's conceivable that you might want both. And because it's kind of conceivable, and because 721 was built with ERC20 as its reference, it has both. Yeah, when you're writing standards, the idea is to, like, as far as is possible, not lock people out of doing what they need to do while still having the simplest, cleanest possible interface. It's very difficult work to write a standard. Like, it's an amazing process, and some people have actually done it as their kernel adventure, which I highly recommend. It's amazing. You get to interact with awesome people. It's an open source environment. It's great, but it's not a small thing because of this particular balance that you're trying to strike. So yeah, and then as I said, because we've inherited this URI storage contract, which only has one function in its token URI, but it inherits from ERC 721 itself, which has everything in it. It returns our balance. It returns who the owner is. It's the name, the symbol, the URI, the base URI, who's approved to spend this token, whether you've got approval or not, whether you can like set approval for all of the people, you know, if you are approved for all, as well as all of the functionality to transfer these tokens. It's all included in the 721 standard itself. So we don't need to rewrite any of that logic in our own contract. All we have to do is write our own, the stuff that we want to be able to do. And in this case, all we want to be able to do is mint an NFT, right? So the only function that we need to write is this mint function. And because I've called my NFT contract Babel, I'm going to be minting books as NFTs. And when I mint a book, I want to have some address who's going to be the reader of that book. I don't like the word owner. I think it's stupid. These are ownerless networks, and we should be experimenting with different kinds of paradigms for guardianship, for stewardship, for readership, rather than ownership. Because again, ownership is a very easy concept. It's very near to us culturally, but it comes with all of this really complicated connotation that is difficult to think through and really muddies the water when I try and develop interesting and creative things, because all of a sudden I'm stuck thinking about who the owner is, instead of thinking about like much more delightful and exciting things like who's going to be reading these NFTs, who's going to be sharing them, who's going to be guarding them, who's going to be, you know, shepherding them through the veil of tears and corporate capitalism until we come out on the other side into the real poetry of cooperatism. Anyway,
we have 4 minutes left, Andy. Let's
excuse me, I'm so sorry. So yes, I want an address for the reader, what other people would call the owner, and I want some token URI where the book lives permanently. And my function is public, anybody can call it, and it's going to return some ID, you know, the ID of the new book that's been minted. And all that's going on here is it's looking at the token IDs field, which, if you remember from our interesting. I'm not actually sure where the token ID field is. Oh, it's my bad. It's in this contract. It's yeah, incrementing our token IDs using the functionality provided by the counters contract. And it's then setting the new book ID to our current ID. It's minting it, and that's being passed all the way back to our mint function, which should be over here in our ERC 721 contracts. So it's, you know, when you inherit contract that inherits others, you get access to the functions in that contract. In this case, we're calling mint, and it will pass, even though mint is an internal function, because inheritance assumes that the contracts are in the same context, right? So we can have a function, an internal function in one contract still be called by another contract that inherits it. It can't be called by another contract randomly on the network, that will fail. But if my contract is deployed and it specifies its inheritance graph, then it can call internal functions across the inheritance graph, which has also caused some security problems. And there's lots of people probably screaming now in real developer circles, but that's how Solidity works. And then we set our token URI using our URI storage addition. And that is the entire contract for now. There are many other things that I would like to say about this enumerable standard, about the URI storage standard. You can go through the extensions yourself. They're really amazing. I would love to speak a little bit about the 1155 multi-token standard. We'll do all of that next time when we move on from this rather simple NFT into actually thinking about how are we going to write tasks to deploy it, what sort of tests are necessary, how do we compile this stuff, where is it going to live, and we get a little bit closer towards having a production ready repository and an understanding of how to write smart contracts in general using these tools, which we will hopefully get to by the end of week 4. So we have 1 minute. I am willing to stick around for a little while after there is another session happening. If you're interested in prototyping and meeting Andre from Deep Work, I highly recommend it. He's 100% more delightful than I am. And I really think that you will enjoy what he has to say. But if you want to stick around here and have any further questions, I'm very willing to answer whatever has come up. Otherwise, I wish you well, go peacefully. Thank you very much for 2 hours of your delicious time. I hope that I didn't bore you too much with tools and other things.
Thank you very much for your time, Andy.
Thank you, Andy.
Andy.
Yeah, we love
Thank you,
spending time
Andy.
here. Thank you for holding space.
Thanks so much, Andy.
All that stuff.
Thanks.
Bye.
Yeah, Andy, it was an amazing meeting.
It was really great. Thanks, Em.
We'll get to real NFTs one day, maybe. No promises.
Thank you, guys.
Thank you. Thank you very much. Thank you.
Andy, one of the things I had a question about is more so around your potential extensions that you use for VS. Yeah, I mean, are there some ones that you highly recommend? Are they a big part of your workflow, or is it really not that important?
The Solidity one by Jean Blanco is really critical for me. It's very, very helpful. The others, not really. And that's just not because I'm honestly not the greatest developer. I spend equal amounts of time between, I spend more time writing English than I do writing code. So
okay, understood.
That should indicate to you that there are many people.
Thanks for the honesty.
Yeah, they're much better than me at developing. And you for introductory sessions, wonderful. Listen to me, but anything else, take a very large pinch of salt, because there are many people who are much better.
I think your linguistic skills definitely apply to coding as well.
Thank you, Alban. I really appreciate that.
Yeah, there's many more. I think we can curate the best extensions and all these little tips and tricks over the course of these 7 weeks that are left.
I would really love that, Sid. Yeah, if you did it sort of incidentally, it would be hugely helpful.
Yeah, so that'd be awesome. I want to make myself, I want to give myself the most professional setup possible, so that whatever the pros use to code, I want to be learning from the first principles of what all the best coders use. and start from there. Just like everything else I do, if I like when I did pro gaming, I would only get the stuff that all the pros are using and I'd start from there. I wouldn't settle for anything less. So I want to do the same thing for coding.
Yeah, so yeah, the first step could be installing Linux either on a virtual machine, on your Windows machine, or doing a clean
Okay.
install as Andy recommends. So yeah, that would teach a lot about computers. But
Oh yeah,
but yeah,
I've installed OSs on virtual machines. So I mean, Linux is, I just haven't done Linux before.
yeah, then I think having a dev setup on Linux would be very helpful in a virtual machine. So
Thanks for that.
Andy, where